ho, ho, ho. That's my famous catch gesture. It's not what he's doing. Elon Musk recently tweeted, and this is something he's been talking about for a while, but it's recently resurfaced, about making the entire United States, at least, powered by solar power. And to do this, he said you could just put 100-kilometer by 100-kilometer square of these solar panels out in the desert, Texas, Arizona, something like that in the United States, and that would be enough to generate all the electricity that the United States needs. Now, this Elon Musk is a fan of kind of brute force calculations, and so am I. So let's go through his. So 100 kilometers aside equals 10,000 square kilometers. So you're talking about sides that are about 62 miles long. I know that because that's how far it takes to get to space. And it would take you on the highway maybe about an hour to drive past each side. So we're talking about a sizable amount of space. Thankfully, the United States has a lot of empty space to offer and a lot of sunny space. Now, how much does the United States need in terms of electricity? Well, there's various organizations, various statistics you can go to, and that is about 425 gigawatts, or in common parlance, gigawatts. I was in my first day in my thermodynamics class in college. I raised my hand and I asked my professor what a gigawatt was, and he said, "Kyle, it's just gigawatt." And then I had to leave. I just had to leave. Anyway, so it really happened. I thought I was being funny, but I was just being stupid. There's a difference. So about 425 gigawatts. That's what the United States needs. Now, the sun, the sun hits every square meter of Earth with about 1,000 watts. So about 1 kilowatt per square meter. However, not all of the sunlight can be used for photovoltaics, PVs, and in terms of their efficiency of photovoltaic cells, you do not get all of their efficiency. Both of their efficiencies is about 20%. So about 20% able to get from the sunlight and then 20% efficiency in the photovoltaic. So if you multiply all of these values together, 10,000 square kilometers, and then you get the 1 kilowatt per square meter, multiply that by about 21%, then by about 24%, you get this final value of about 500 gigawatts, or gigawatts, as smarter people say. So about 500 gigawatts. Now, you will notice, there's not a whole lot of math here, you'll notice that this number is bigger than this number. I don't know what accent that was. But this would theoretically be enough energy to power the entire United States. So Musk, in a brute force calculation kind of way, is right about this. If you picked just 60 by 60 miles somewhere in Arizona that was sunny enough of the time, you could power the entire United States. Would you want to do this? No, of course not. I think this is kind of just a thought experiment. If you had a single giant solar panel, it'd be incredibly fragile. Think about how you need to protect it. The batteries that you would need, it would cost trillions of dollars. One single event or like bad weather or like an earthquake in the area or whatever. I don't know if they're very earthquake prone over there, but it could wipe out our entire energy grid. So I think this is more of an experiment, thought experiment to show just the power of the sun and the power of emerging technologies right now. This is not a lot of space at all to power the entire United States. Of course, you could use you wouldn't even need as much space or as much money to build the equivalent amount in electricity production for nuclear reactors, but people are afraid of those, even though they're safer and more energy efficient and cleaner. I don't know. I'm big on nuclear, like Bill Gates. Hello, and welcome to another edition of Because Science Live, the live edition of this show where I try to take all of your comments, questions, and corrections off the top of my head. Look, I'm not a working scientist. I don't have a PhD, but I spend my days looking into many sciencey and nerdy things, and I might be able to learn something with you together. So if you have any questions for me, you can put them in the chat on YouTube, and if they're good and they're not spammy and they're not just trying to get my attention, Voice of the Void Nate will read them out. What up?
What up, Kyle?
Oh, I don't know. I don't know which direction is which in here.
I'm everywhere.
Ugh.
Our first question from
Everywhere?
Diego.
Okay, yes.
Why do we see in slow motion when drunk or drug, like in Dread? Excuse me.
My favorite action movie, Dread?
Yeah.
Oh, with, what did I call him last time? Keith Urban?
I call him Mr. Frowny Face.
Mr. Frown. Send me a lot of paperwork if you just confess right now. Yeah, that movie's awesome. Anyway, a little correction here. I don't think you see in slow motion. I don't think you think in slow motion. You are so let's be more clear. If you are having a difference in how you're seeing something or thinking about something, you are having a change in perception. And I won't say that this is a made-up thing. I mean, there could be a drug that made you perceive the world in slow motion, because we know there are drugs and chemicals and pharmaceuticals and what's the word I'm looking for? Psychedelics that can change your perception and give you an altered state of consciousness. So you can have visual illusions, you can have cognitive illusions, you can have emotional states incredibly altered. So any drug that is making you see in slow motion or what have you, if you were drinking or what have you, is changing your perception, changing your consciousness. We know that this is possible. We hear reports from people that have done psychedelics like LSD or MDMA, DMT, these kind of things where it changes their perception enough where they lose their feeling of being a person, like oneness, or they suddenly feel an intense connection to everything around them, or they have visual illusions where lights are moving around. This is a change in perception brought on by some pharmacological change. So that is absolutely possible. You would just have to find the right drug to do it. I know there are some drugs. I mean, if I was hypothetically in California where, say marijuana is legal, edibles affect perception of time, I hear. So, you could feel like the passage of time isn't working with what your brain is trying to account as how much time has passed. So all of that's very possible. You just need specific chemicals to target what you want and then do that kind of thing. I think DMT may have been linked to near-death experience kind of perception and illusions. So it can have a radical effect on what you think is happening to you. What's next?
From Nick Pratt.
I don't endorse. I don't. That was all just factual information. I'm just going to get that out there.
From Nick Pratt.
Yes.
Why can't we make a perpetual motion machine?
The universe never gives out a free lunch. And if you want to get more technical, entropy. So in the universe, it always takes. Energy can neither be created nor destroyed, but it can be transformed into different forms. When this happens, and because of entropy, the natural universal process of things going from more ordered states to less ordered states, there is never 100% efficiency. Even in the most perfect engine, some energy, when it is, say, transformed from like the motion of a piston to the spinning of a wheel, and that kinetic motion is transformed, you are still losing some energy as it's transformed into sound, into heat, and frictional losses, stuff like that. So you can never have 100% efficiency because of entropy in the universe. So in a perpetual motion machine, what you are expecting then is to have no losses at all. Perfect energy transfer. You can think of a pendulum that would never stop swinging. Now, if this pendulum was never stopped swinging, you could hook this up to some kind of energy generation, like a turbine or whatever, and this could generate infinite energy. And suddenly, you are getting energy for free. You are getting work from nothing. You are creating energy out of nowhere, and this energy you just can't get it for free. You're getting a more ordered thing out of a less ordered thing. So we cannot have perpetual motion machines, yes, because there's no free lunch in the universe. Everything has to be paid for by something in terms of energy. And if you see anywhere on the internet, like, oh, this could be a perpetual motion device, and the government just covered it up, and they killed Tesla because he did. No. it's not Tesla's problem. It's a universal truth that this is the case. It's not like some guy figured it out in his garage and it's one of those ads on Facebook that are like, doctors hate him because he made a perpetual motion device. No. No, he'd have a Nobel Prize and a lot of money. All of the money. He would have solved whatever. Getting off topic. I'm angry at those ads because I want to click them. Doctors hate him. There's one trick. How does he do it? He does it.
From Greg Swanson.
Oh, hello.
Kyle, love the show.
Hey, thanks.
What are your thoughts on the Cybertruck?
I don't like it. It looks like it was rendered on the PlayStation 1. It looks like Lara Croft on PlayStation 1. I have significant others that really, really like the truck because they're kind of cyber in their aesthetic, but it's not for me. I'm all for electric vehicles of all types and that are efficient and use energy efficiently and that are better for the environment, but I don't care for the design. If you're going to go, what was really smart about what Elon did with Tesla is that he took something that was perceived as weak and geeky and electric vehicles, and he made it into a sexy sports car. Like, say what you will about Tesla Motors and stuff. Tesla's, the Model S, the Model D, they look great, and they're really fast, and they're really nice. So he made something that was perceived as non-luxury into a luxury item that people wanted to own. I think that was a good idea. I don't think he did that with the Cybertruck. It wasn't like, now, what was so smart, I'm thinking about, I want a Tesla, so I'm thinking about this. It's in this way. He made the argument for getting an electric vehicle easier. That's why Tesla has been successful, is that in my mind, it's like, well, I want to get an electric car. Well, why wouldn't I get a Tesla? And I don't think he did that with the Cybertruck. We're like, well, I want to get a pickup truck and go to work, and I work in construction. I need a truck, and I want to go electric to be conscious about the environment. Would you get a Cybertruck? I don't know. So I'd like to see the same kind of shifting of the market for the Cybertruck. If it looked great, like the Tesla models and stuff, to me, I think it would have been better. But I have no problems with the vehicle itself, like its stats and stuff.
Okay, so this next username, it's long, but it's great.
Okay.
Username is that one dude who isn't in the same room as you.
Oh, I know him. Don't see him very much.
Is a planet that is entirely water, like Camino from Star Wars, possible, where there's some land but very minimal?
When you mean entirely water, what do you mean? What was Camino? It wasn't water all the way through, right? A planet that is an entire, I'll say it this way. A planet that is all ocean all the way around seems fine to me. This could be something like, Enceladus or something in our own, which is a moon, in our own solar system where it's just a layer of water around a rocky core. That is fine. That seems like, if the Earth could have been different where it was mostly water or almost all water. What I do have a problem with is Naboo and the Gungans, because it seems like Boss Nass, is that his name?
Yeah.
It seems like he implies that to get over to where they're being attacked and Qui-Gon is here, it seems like he implies there's a way through the planet's core that is water. No. If you have liquid water going through the planet's core directly, like through the middle of the planet, this seems to imply that the planet doesn't have an active core, which would mean like no magnetosphere and the planet would probably be dead around the star that it's around. Or, if that's not a problem, if you have the mass of a planet, the gravitational forces here that act to make this planet into a spherical shape, this is one of the ways that we define planets here in our own galaxy. It has enough mass to crunch this down into a spherical shape. And if it has that much gravitational force acting on it, if you have something like water at the center, I believe it will be under so much temperature and so much pressure that it wouldn't be water down there anymore. Do you know what I mean? There's a reason why we have molten liquid metal, molten rock at the center of our planet. Heat and pressure. You would not just have swimmable water down here. And there can't always be a bigger fish. There's got to be one fish that's the biggest. Man, it's like Qui-Gon knew very little.
From Michael Hay.
Just leave me hanging on a Qui-Gon.
Yeah.
Qui-Gon slam.
Sick Qui-Gon slam.
Thanks, bro.
From Michael Hay.
Ooh, hey.
How do you feel about using mill as a win condition in Magic the Gathering? And do you have a favorite mill-based card?
I played a mill deck for a while, and I still have it. Do I? Yeah, I still have a mill deck. It's Lazav Demir Mastermind. Mill has been very strong throughout the years in certain environments. So I know there's been standard decks when, like, I think there was an ally deck that used mill as a win condition. I think it's viable, but I only think it's really viable against one opponent at a time. It's kind of like Infect, where mill can be really strong if you're playing EDH against one person, but to mill everyone out, to go through the process, which can take many, many turns, and actually win the game with mill, I don't think it's what I would consider viable. I would not build a powerful mill deck that, I don't know if it's, take two commanders, one is mill, one isn't. I think mill is always going to be weaker, I think. And that's like Infect. People are really afraid of Infect, but it usually only kills one player and then that player dies. So that's my Magic rant over. But I do have a mill deck because it's fun. But if you're looking to win a lot, probably not.
All right, probably last question.
Copy.
From Till Hansel.
Hello.
Greens from Germany.
Oh! You prevented me from doing a German accent with that name. Hello, Mr. Hansel.
Anyway.
Hello.
What would happen...
Or Miss Hansel. I apologize.
What would happen if we took all the atomic waste and shot it into the sun? Would that be a valid solution for the waste, or would it be a problem?
So we've talked about this a little bit on the show, I think during a couple lives ago. But getting rid of atomic waste is an issue. I said atomic energy is cleaner, and it is cleaner than coal, and it is safer than coal, and it's more energy efficient than coal, and I think we should switch to nuclear power in a big way. But the waste it generates, there's a lot of it, and it's very dangerous, so we don't know exactly what to do with it. One goal would be, one way of getting rid of anything, really, would be to shoot it into a star. However, we are currently orbiting the sun crazy fast, like 30 kilometers per second fast. And therefore, to launch something into the sun, if we just pointed a nuclear trash gun at the sun and fired, it would actually take a curved path because the Earth is still moving and miss. So what you'd want to do is fire out a rocket that goes in the opposite direction, 30 kilometers per second, and then falls directly down into the sun. So in other words, you have to cancel out the Earth's velocity, and then you can safely shoot straight towards the sun. It turns out that going 30 kilometers per second takes a lot of fuel. It's not to say we couldn't do this, but the amount of fuel, because it costs thousands and thousands of dollars just to get 1 kilogram into space, I think it would be incredibly cost prohibitive to do this. To get all the nuclear waste onto a big enough rocket or enough rockets, and then use this much fuel to cancel out all of the Earth's orbital velocity and then fall into the sun, which would take about 65 days, I calculated once. I think it's logistically a nightmare, and it costs way too much money, and no one would ever go for it. I think you could spend a fraction of the money figuring out a safe way to store it here on Earth, like just, I don't know, throwing it down a couple mile mine shaft or something forever. Or, just never figure it out and you just keep moving it around Superfund sites until everyone gets mad and then the politicians do nothing. Who knows? Thank you for watching this edition of Because Science Live. Whew. We had a week. This is a week. Anyone watching in the UK knows that this has been a real week. Thank you so much, everyone who's been watching me and supporting the channel. Next week, we will not have Because Science Live, because even here in the Void, we do take breaks for the holidays if you celebrate. Happy holidays. But next week, we definitely have a new Footnotes addressing your notes from yesterday's episode, and we have a new episode, and it's a fun one. It's coming out the same day as early screenings for Star Wars, and it's Star Wars related. But it's fun. It's not like subverting your expectations, you know what I mean? So I hope you have a wonderful rest of your weekend. Think about clean energy and be nice to each other, because this is all we got.